Okay, so here what we've got is a little AP versus a GP question. Kim and Alex start jobs at the beginning of the same year. Kim's annual salary in the first year is $30,000, increasing by 5% at the beginning of each year. And Alex is $33,000 the first year, going up by $1,500 at the beginning of each subsequent year. Show that in the 10th year, Kim's annual salary is higher than Alex's annual salary. Well, essentially what we've got is an AP versus a GP. Let's set up two parts of the page here. I think we say that if we've got Kim on this side and we've got Alex over here. Now, well, to work out which one's the AP and which one's the GP, the one going up by a percentage is going to be the GP. So Kim's annual salary in the first year is $30,000. So her first year is $30,000, and Alex's is $33,000. Now Alex's goes up by $1,500 each year, so it's got a common difference. It'll go $34,500, then $36,000, and so on and so forth. And whereas Kim's will go up by a percentage each year. Now that means that the ratio here is not 5%, because it's going to go up 5%, so it will be 105% of what it was, or 1.05. Okay, so it is not 5%. If she only got paid 5% of what she got paid in the previous year, well then obviously she's going to get paid a lot less. Okay, so what we're interested in both cases is T10. Okay, now T10 in this case, well that's 30,000 times 1.05 to the power of n minus 1. Sorry, that should be 10 minus 1. That should be a 10 in there. Salary's gone up 9 times, so it's 10 minus 1 gives me 9. If we calculate that one, Kim's salary in the 10th year will be $46,539 and 85 cents. Okay, in the same way, T10 over here. Now, let's not get confused. This one is a GP, going up by a percentage. This one is an AP, going up by a fixed amount each year. Okay, so T10 over here is A plus n minus 1, 10 minus 1, multiplied by D. Okay, now if we work that one out by going straight to our calculator, we find that it's 46,500. Okay, so therefore we found that Kim is greater than Alex in the 10th year. And what you might find is in the 8th or the 9th year, Alex still has the upper hand, given that he or she started $3,000 higher. But what you'll find is, as this progresses, if we looked at their salary in the 30th year, well, Kim's going to be earning a whole lot more. Now, part 2 here is, in the first 10 years, how much in total does Kim earn? Now, Kim, of course, is our GP, which means we're going to need to go find the sum here. The sum of the first 10 years is A, which Kim is earning $30,000 in the first year, times 1.05 to the power of n, 10 years, minus 1, over 1.05 minus 1. Again, I just go straight to our calculator here. While I type it in, we should be expecting a pretty big number, because if she's earning $30,000 in the first year and $46,000 in the 10th year, well, if we just go and add those numbers up, we're going to be expecting something in the hundreds of thousands of dollars. And what we do find is that over 10 years she has earned $377,000, sorry, $336.78. Makes sense. First year's 30, 10th year's 46. We can't just go and average it out like an AP, but if we did just go and do that, we would get something in that ballpark there. So she's earned about $377,000 in the first 10 years. Now, back to Alex here for part 3. Every year, Alex saves 1/3 of her annual salary. Well, it turns out Alex is a she, not a he. How many years does it take for her to save $87,500? Well, few ways we could do this. The main thing I would say is she needs to have earned 3 times that. Because if she's going to save $87,500, she's got to have earned 3 times that amount if she saves 1/3 of her salary. So she's going to have earned $262,500 in N number of years. Now, of course, Alex was our AP. Alex was our AP question with a first term of 33,000 and a difference of 1,500. So what we're looking for here is we're going to be going and finding N. N is our question mark, but our sum of N terms is 262,500. Okay. So in that first year she would have saved $11,000, and the next year she'll save a little bit more than that and a little bit more than that. I'm just thinking if she's going to save $87,000, I'm thinking somewhere in the vicinity of 8, probably more like 10 years, just as a logical answer, but we will go and confirm what that is. Let's go and substitute in here. So we might do this on a new slide. Whoa. So what we end up with here is our sum of 262,500 equals N over 2 outside of, or 2A was 2 times 33,000 plus N minus 1, don't know what N is, multiplied by D. And of course our difference was 1,500. Alrighty. We've done one of these before. I'm going to go neaten them up. Alright, I'm going to straight away multiply by 2. And now with N on this side, 66,000 plus 1,500, N minus 1,500. Over here on the left of my equation, I end up with 525,000. Okay, big numbers, but what you're probably going to find is they're going to neaten up quite nicely. So here I'll end up with, okay, let's keep progressing with it. We end up with 1,500 N squared plus, how many lots of N do I have? 66,000 minus 1,500 is 64,500 N. And I've still got my 525. So what we end up with is 1,500 N squared plus 64500 N minus 525,000. That should be another 0 there. Now what I'm hoping is there's a common factor here of 1,500. Let's check. And there is. What we end up with is N squared plus 43N minus 350 equals 0. I'm not seeing a quick way to factorise that, so I'm just going to go straight to the quadratic formula. So N equals minus 43 plus or minus the square root of 43 squared minus 4 times 1 times minus 350 all over 2 times 1. That'll come out to be minus 43 plus or minus 57 on 2. Now, of course, if we go minus 43 minus 57, that'll give me a negative answer. In fact, this did factorise pretty nicely. But what we end up with is minus 43 plus 57 is 14 on 2, or 7 years. It takes 7 years to save that amount of money. So I was a little bit overzealous with 8 or 9 years, but we're in the right ballpark. Now, the other thing to note here is we should write down the fact that N equals, it'll be negative 50 is not valid. of course, we're talking about n number of years that he's worked. Can't have worked for negative 50 years. So there we have it. Look, really, with something like that, that's quite a long and convoluted process to go through all this yucky quadratic formula, not particularly nice common factors. Realistically, you could just go and guess and check in the ballpark of 6, 7, 8, 9, 10 years and see which one gets you in the right area. All right, I hope this has been helpful. As always, correct formulas, correct setting out, get your information down, and you should be fine.